Hey everybody, this is Larry, this is me, this is Q2 of the day. Me trying to do a bonus question because usually I've done the daily problem. So yeah, I'm gonna use the random thing, so we'll see. We'll filter by to do and then do a pick one, and then we'll see if that's very often it's premium question, but maybe not. Let's see. I don't know why it's so slow actually. Dong dong dong. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and come do it with me, even though it's a bonus problem. It's hopefully new for me. And I have an 850-day streak. Yay, so we'll see. This I may not do every day, but today I'm doing it, so we'll see. Today's problem, and I haven't done it, yep, confirming, is 1131 maximum of absolute value expression. So given two arrays of integers of equal length, return the maximum value of this thing where the maximum value is taken over j minus thing. Okay, so this is a thing that actually comes up maybe more often in competitive programming than even, I don't know, normally. But here, I assume I actually skipped ahead a little bit because I really should have checked first, which is the n, right? N is 40,000, which means that n squared is going to be too slow. But obviously, if n is, say, 100, then you just do it and then you forget about it. You set it and forget about it. But yeah, but here, you're trying to max this number, right? And one thing that you can do is, for example, just taking out the i's and the j's. So what does this mean, right? So this means that there are two components. This is that absolute value of this one's a little bit potentially tricky, but we can do it, right? Let me actually put in a second line. But basically, let's take out the I elements and the j elements, right? Then you have this plus I, and then you have the subtraction of, and this part will make it a little tougher, but we can do it. Minus j, right? So is that the way to do it? Well, let's see. So these are the i's and these are the j's, but the absolute value is adding, some complexity there for sure. And because the signs could be negative here, right? I'm trying to think how would I do it in a smart way. Because you can't just, unless I misread this, yeah, you can't just like quite just do it this way, but maybe another way of doing it. You could do it with j as well, but let me think about this. So the ideas that I'm thinking about is like some sort of brute force. You have three formulas, right? And then this absolute value has to be one of the four possibilities, right? And what do I mean by that? It means that it is either this, or maybe another way of saying, well, there's four possibilities for this one, but I actually was thinking about 8 in my head because you have this thing, right? And then here, and they're three operators, so that means there are 8 possibilities, right? You can also do something like this. Oops. What the? Wow, this one is harder than I. Or basically the 8 possibilities. And then, but then how do we look it up in a good way? Maybe that's where I'm a little bit off. And then dot. I'm not gonna, that is usually a good idea to kind of make it linear, but but that seems to be, or like I'm not quite clear on how to do it. Like if we want to do the maximum value, you can't just arbitrarily take the plus, right? You can't just like maximize this because then oh because then the thing is that this, like, if you take a number, okay, so this part, that's why I wanted to convince I and J, is that we can assume that maybe we can do something funky here. Okay, so we can assume that, let's say J is greater than I, we just go regular loop, then we can rewrite this as this, right? Oops, let me erase this for a second. Then we know that this is J minus I, right? And can't really sort, can we? Because if we sort, then it'll be a little bit savage. But okay. Wait, I meant to take this out, I suppose. Well, I mean, depends on what you mean. But yeah, but now there's no more absolute value. Can we do something similar to the other ones, right? I wanted to say that if we sorted, then that would have been better, but maybe I don't know this one. I have to think for a bit. They don't even give you an example of where that is. They should give you at least one example, but maybe we can play around with some examples and I can maybe visualize this a little bit better. I'm definitely do not know how to solve this one, which is good because I did wanted to, the part of my motivation for these is to practice problems that I would not have normally practiced on the about right difficulty. This is only a medium and I'm struggling. But yeah, so for, what does that mean? Let's say we match these two. Well, the contribution, right? But that's still 5. Can I take the absolute value out in a good way? I don't even think so. So wait, so let's say we're looking at J, right? Well, can I get rid of these absolute values? I guess given this, I mean, this part is pretty okay. So then we can minus I from these two components, maybe, as a way to add. But is there any way that we can do? I don't really have idea here, huh? 40,000 is also a weird one because n squared is definitely too slow, but we can definitely do n log n or even n squared root of n. So the maximum value, what does this mean, right? It doesn't have to be that. So this is linear combination, but so that -1 would have been 4 is good, but 5 is even gooder, and 6 is even doubly gooder. So that's 7, 3. So that's not actually the best one though. The best one would be, where do you get 13? Oh no, wait. This is 7, 3 plus 3. I wonder if there's like some sort of walking algorithm that I can do. But the I and J makes that weird, right? I mean, this decomposition is pretty straightforward, and this can be because we assume that so let's say we take the negative of the previous number. Is that better? Or is that worse? If it's positive, let's see. Because the thing is that you can't even, because if it's just one dimension, then I can figure out how to optimize it. Like in the sense that, you know, there's a greedy way to do it maybe, but what does the max let us do, right? Well, let's see. This is definitely just, you know. So let's say the I components. What are the I components? Well, is this plus I or minus I? Do we want to save it that? I don't think that's good enough, because this number can be bigger than this number. Then you can't just like, I don't think all the cases are accounted for it. Let's say, you know, let's just try one example. So then we have -1 and then 0. This is the first number in this input, right? So then we store 0, right? And then now the second number, we have 2 and a 4. Maybe we have a -2, -4 and 1. Is that equal to so this is either 6 or 5, right? That is, I don't know that makes sense. I mean 5 or 7, I suppose, but it depends how you want to do it, because this is -6, or this is yeah, -5 and this is 5, right? Is that the right answer? No, right? Because this is 1, this is 5, and then you have another 1 for the index, so that's 7. All right, so this should be 7. And of course, you can like add. Can you add them? Is that right? That would be 7, but I feel like that's just, I don't know, maybe luck. So 3, 5, and 2. What do we have here, right? Well, here then we have, compared to the 0, we have 8, 10. So this is 10 if I did it this way. I feel like the signs here makes it confusing, really. 10 for the first number, and then the second number, this is 7, so this is 3. Is that right? It is right, but I don't know that this, I mean, this, if every number is positive, I feel like maybe I could have be convinced. But also, like, these are increasing numbers, right? So I don't know that I'm that convinced, to be honest. Let's try it the other way. Alright, so then here the first one will store 1, 0 and 0, 0, which is 1. And the second one we want to compare yeah, actually we would store, yeah, and then here we would maybe store the minus this, but that's the thing, right? In theory, this would, the J part would be the subtraction. So then this is 4 plus 1 is 5. So this is 5, which means that compared to this is a 4. But I don't think that's right. That is a 6, right? So this is already wrong if we just do like a linear combination thing. Okay, I just wanted to confirm that that was wrong. Can we do signs or something? Or can we bisect the thing into 4 parts and then do the biggest of each component? Maybe, right? Like we said that there's like we did say that, you know, this is positive, but this could also be, is it the max or the min? The difference of the two numbers, I think that's the problem, right? Is that I don't know how to get the max of an absolute value. Can I reduce this? There we go. Max of absolute differences. I guess it is just iteration. Yeah, I mean, I guess so. I'm trying to think in my head a little bit more. I think I think you just. I was hoping that there was a easier way of doing it, but I think yeah, I just need to kind of just do it. Okay, so then now let's just say, yeah, let's just write it out real quick then. Okay, I mean, yeah, I'm convinced that. I guess I was just trying to avoid the way that I knew. I think that's something that I've been bad at as well. So we have 2K. So we have this. We know that J is going to be smaller, so so I think that's fine. Yeah, and then we have and then so this is what we're putting in the in the table, maybe, right? Yeah. Hmm. Let me think about this, right? And then now, yeah, so we have to do these 4 things. I see. Okay, I think I get it now. I think basically you have these 4 things, and then basically it's yeah. Okay, I think I get it. Wow, that is an annoying part. I think basically there are only 4 possibilities, right? So we have to kind of enumerate them. Is there really, that's why I was trying to think whether there's a easier way. But basically the answer is either but I'm still trying to prove why that is the case. So it's either this, maybe I'll rewrite it to the left, minus minus plus j. So I'm trying to think to myself a little bit. So I guess that is the case. It is what it is, right? So let's just brute force the 8 combinations, maybe. Don't know. I mean, we can. I think we can simplify it this way, so it's fine. And then here we have. Okay, I guess the idea is that we just cancel out things, right? So it's either this or well, in this case, let's actually rewrite this a little bit. We would have something like this, and then we subtract it from here, right? And here, technically, we would actually have something like this. Oops. Right? Yeah, and then, oh, I don't know why I said the other one. And then, is this right? So basically, and here we want the max of this and the min of the other one, right? The max of the function is equal to the max of this minus the min of this. And then here it is slightly the same. Where I am just blanking out. Okay, and then here we have, maybe I should have not done this in my head, but okay, so then the other way of doing it is arg of j minus arg of I, so it'll be this, so it'll be negative of this because this is positive because we're subtracting for some reason. Yeah, and that's the other one. And then the other one, it would be negative minus yeah, minus arg1 of j minus arg2 of j plus j, right? And here we assume that the j is bigger than I so that we can be a little bit easier. But I don't know if that, maybe that's right, maybe that's wrong. I think that's right. And then the last one is just negative 1 of I minus R2 of I minus I minus negative 1 of j minus R2 of j plus j, right? And I think now we have these four things, and we just have to, in this case, maximize this and minimize this, right? I think that's okay. Yeah. Before I go further, I'm going to ask for a hint. Okay, this is exactly what I did. Okay, fine. I was worried that I was. I mean, I don't mind implement it, but I just didn't want to spend that much. I always spent 20 minutes on this, but that's kind of a hard problem to think about. I don't know. Maybe I should have been able to do it. But okay. So then now let's just say we have for x, y, or I, x, y maybe in enumerate enumerate SIP of R1, R2. Okay. So then now we have four things to measure. So then let's just say max of is equal to, I don't know, negative infinity times 4, and then min, right? Min, let's just say infinity. Okay. Because these have different signs, I think we just have to parse them a little bit differently, maybe. Okay, so best is equal to 0, say. Yeah, okay. And then now, okay, so max of 0 is equal to max of we want this side to be max, so that's x plus y minus I, maybe. Yeah. And I'm just doing the cases. Okay. And then now we're doing the min. X plus y plus j. Right. Okay. And then now the answer has to be, and we could have done it forward, which is that best is equal to max of best of mx sub I minus mx sub or mn sub I for I in range of 4 maybe, and then we return best. Let's run it real quick. Oh, whoops. We want, so this is return to this, we want the max of this, so J is not, oh whoops, I guess I is the current ones. We establish it. Is this right? I think this is right though, maybe. Max and min doesn't, oh, okay, maybe not. Oh, well, this is just a typo though, or copy and paste ever. Hopefully this is right. Okay, this is still not right, which is now a little bit sadder. I think the tricky thing here is that maybe I need to do it at the end, because I think maybe this matches itself, and that may be a wrong answer, obviously. How do I make it so that it doesn't match itself? Let's see. Yeah, I mean that seems right, but is that not right? What am I missing? So we want to maximize this, and we want to minimize this. Did I mess up? This is very awkward, honestly. Well, oh wait, no, maybe this is weird, the way that I set it up, because now, okay, let me rewrite this real quick. So then now, instead of writing it, I'm used to writing it like this, but clearly I'm a little bit off. So then one answer would be that's j minus I, right? And then the next one would be, let's say, j minus a sub 1 of I, and then everyone else is the same. And then the third one would be everything is different, say. And then the last one is back to ij here, right? Okay, so then now let me get my signs right. So 1 is plus, 2 is plus, minus I. Okay. The second one is minus I, plus I, minus I. Okay. The third one is I guess minus I minus y. And then the second one. Well, I mean, I did in the different order, but I feel like it should be okay. Okay, let's just do it for consistency's sake. Let me just move this here and then. And then here there's negative on the i's and an I. Okay. Here on the negative side, well, we are subtracting it, so we actually are subtracting the positive and the positive, and then this one we're not subtracting, so actually this is negative, isn't it? Because this one we're adding the sign. So okay, maybe that's the case for all of these actually, so maybe that's why. Okay, that's a silly mistake actually, but don't know that I explained it this well. Let me see if I get it right first, and then we'll talk about whether I, but it seems like it would be very, I wouldn't say it was unlikely, but it would be hard to get it right by accident. Wow, this is kind of tricky. I don't know that I kind of knew this technique, but I was just too lazy to do it, to be honest. I thought that maybe I could try to find an easier solution, but which has been my issue lately. But the idea here is that there are only 4 possibilities, and you're trying to maximize each one for the I's and the J's. And I think one thing that I struggle a little bit is try to figure out how these don't overlap. But I guess if they overlap, they would just be 0, right? Because I guess this is, yeah, the way that I lined them up, I thought that would be a little bit different because I just wrote the formula a little bit incorrect with respect to the minus and stuff like that. Or because I minus here, but then I didn't do the double negative. But actually, these are just the same numbers, right? So that's a little bit awkward. And we just have to take, it's either the max of this formula or the max of this formula or this formula or this formula, and this kind of tracks all 4 independently. And we could maybe we could have written this a little bit better, differently as well, just like in terms of easiness. And then we could have done like, sine x, sine y, or sine, maybe just do something like this, and 1 minus 1 for sy and 1 minus 1, and then we have something like max is equal to negative infinity, min is equal to infinity. This is just me doing some optimizations now that I don't, whatever about it. And then now we can do, yeah, max is equal to max of max, and then, yeah, because I didn't realize that these are exactly the same until afterwards, I suppose. But let's see, right? So sx times x plus sy times y minus I, right? And then min is the same thing. We could probably have stored that for extra thing, but that's fine. And then at the very end, best is equal to max of best mx minus mn. And I think we're Gucci here. I don't know if this is that much faster, but it is easier, cleaner to read. So yeah, yeah, actually makes sense for it to be slower because we have more loops and weird stuff. But it is much easier to read. I feel like I probably could have done a little bit faster, but I'm okay with this one. So yeah, cool. Whew, let me know what you think. This was kind of a tricky one. I didn't remember I do remember a version where it's only this, but I didn't remember it being quite this annoying. The absolute values, maybe I'm just a little bit out of shape on. Oh well. Anyway, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Goodbye.